Hello, Common Core Geometry kids. The first thing you must do immediately is put your calculator in degree mode. Okay, you do that by going to Mode, go down to where it says Radian and Degree, select Degree, and press Enter. It's not selected until you press Enter. All right, so here we go. We're going to use trigonometry to find the measure of the missing sides of right triangles. Okay, let's start right away. Example 1. So let's say we have this right triangle here. Let's say this is 52 degrees. This is 15, and this is x. We want to find x. Number 1, label the sides according to this angle, 52 degrees. So this is the adjacent, this is the opposite. Which trigonometric ratio uses adjacent and opposite? Tangent, right? Remember, SOH-CAH-TOA. So the tangent of 52 is the adjacent over, the opposite, sorry, my bad. The opposite over the adjacent. Now, on your calculator, you type in tangent of 52. So you just type tan 52, enter. When you round this number, you must round it to the 4th decimal place. So you end up looking at this number in the 5th decimal place. Okay? So you have tenths, hundreds, thousands, 10,000. So you're going to round it to the 10,000s place, always. So you end up with 1.2799 equals x over 15. You could put this over 1 if you like. So x is going to be the cross product. Now you could leave the 1.279941632 on your calculator and just multiply by 15. Or you could do 1.2799 times 15. It doesn't matter. Because when you get your answer, okay, I'm going to get the answer to the nearest tenth, it's going to come out to be the same thing. All right, approximately 19.2. So I left the answer on the calculator, and I had gotten 19.199124448. If you used 1.2799 times 15, you would have gotten 19.1985. So it doesn't matter, because when you round to the nearest tenth, we're only going to be looking at that part anyway. Okay? I didn't mean to cross out that 9. You're just going to be looking at this part anyway. All right? So it's going to come out to be 19.2 either way. All right. Let's take a look at another example. Example 2. Let's say this is 28 degrees. Let's make this 10, and we'll call this x. Okay, again, label the sides according to the acute angle. So this is the opposite, this is the hypotenuse. So we have sine of 28 is opposite over hypotenuse. Now on your calculator, you type in sine of 28. Make sure you make yourself do this, guys. Don't just copy notes for the sake of copying notes. Then you're not going to be getting what you're supposed to be getting out of this. So this is what I get as the answer, 715,628. But remember, I need to round to the 10,000s place. So this number in the 100,000s is a 7, so it becomes 0.4695 is 10 over x. 0.4695 times x equals 10. And then you divide. And then after you divide, you're going to round to the nearest tenth. So we get 10 divided by, 0.4695. And when you round to the nearest tenth, so we get 21.9, 0.299, blah, 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 blah. We don't even care about this 9. You just care that this 9 makes this 2 round up to a 3. So we get 21.3. Okay, so I did a tangent problem. I did a sine problem. Okay, let's do a cosine problem, huh? Example 3. So let's say this angle is 35 degrees. We'll make this 50 and we'll call this x. Okay, this is going to be a cosine problem because this is adjacent, this is hypotenuse. So we get cosine 35 degrees is your adjacent over your hypotenuse. So on your calculator, you just type cosine 35, which is 0.819152, blah, 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 blah. Okay, you only need to look at the 5 and see that the 5 makes this 1 round up to a 2. Ask your parents about trigonometry and how they used to have to use trigonometry tables. Your life is a million times easier in math than theirs was with regard to that. It was very annoying using those tables. Okay, 0.8192 times x is 50. Divide. So we have 50 divided by 0.8192. Okay, and that comes out to be 61.035, blah, 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 blah. Okay, I'm rounding to the nearest tenth, so you do not care about that 5. This 3 makes this 0 remain a 3. So that would be your answer, 61.0. All right, one complicated question. All right. 2 complicated questions. Okay, I lied. All right, here we go. So those are considered, just average questions. So now these are going to be difficult because it's going to bring back prior information. Let's make this 20 degrees. Then we'll make this, okay, let's see, 70 degrees, because they're similar triangles. When you have, remember, when you have a right triangle with the altitude drawn to the hypotenuse, it creates 3 similar triangles. And I'll make this 15. Okay, and we're going to find the measure of DC. All right, so we can't get the measure of DC immediately. We would have to get BD first. So I'm going to call that Y. All right. So, I mean, there's several ways to do the problem, but I'm going to focus on this triangle on the left first. When you have one side, one angle, you can find the other side. So when I label this, this is the hypotenuse, this is opposite. So I'm going to have sine of 70 is equal to opposite over hypotenuse. And the sine of 70 is 0.93969. So that's going to become 0.9397 times 15 is Y. Okay, so I wouldn't round. I would, if we're rounding to the 10th, just leave the answer sloppy in your previous step. Because if you round too far, you're going to end up with something called rounding error, all right? So this is 14.0955. Okay, so now I'm going to go to this triangle on the right. And I'm going to use the 20. So this is going to be adjacent, and this is going to be opposite. So I'm going to have tangent of 20 is opposite over adjacent. And the tangent of 20 is 0.36397. So that's going to become a 10, which will make that 3 become a 4. That's how you round. Okay, I don't assume my kids know how to round because I've seen students really struggle with rounding in high school. So I have 14.0955 divided by 0.3640, and that comes out to be, to the nearest tenth, 38.7. Okay, so that is a multi-step problem. Okay, so be prepared for these things to happen. That's what I'm saying. Okay. All right. All right. Example 4. Yes. Just make. Oops. Sure. All right. So example 5. And I know you have to go slower than I do. You have to pause the video and copy down the diagrams. Okay, I'm well aware. Okay, so I have these right angles. I have this right angle and I have this right angle. Let's make this 48 degrees. We'll make this 12. Okay, these are not similar triangles. In the last one, they were similar triangles. We will make this 71 degrees. And we're going to be finding KL. Okay, so I'll call this X. All right, so this is going to be similar to the last question. You're going to have to first find JL. So to find JL, you may want to just pause the video, do it, and then check your work. So this side is going to be adjacent. This side is going to be opposite. So this time we're going to start off with tan 48. Opposite, right, over adjacent. So that's going to be y over 12. Okay, tan of 48 on your calculator. Tan of 48, so tangent of 48 is 1.1106. Cross multiply, 1.1106 times 12. Okay, we're going to leave the answer like this because of round off error. That's why. So this side is 13.3272. Okay, so now we start all over, focusing on this triangle. So if you look at the 71, this is now the hypotenuse, and this is the adjacent. So we're going to use cosine. So we have cosine 71 is equal to the adjacent. Well, the adjacent is x over the hypotenuse, 13.3272. So cosine of 71 is 0.3256. That's what it rounds to. And then when I multiply 0.3256 times 13.3272 to the nearest tenth, that comes out to be 4.3. Okay, kids, that's enough for this video. See you in class. Thank you. Final question. Okay. This one's going to look very confusing. I think this is example 5.